I want to welcome everyone to the Texas Children and Nature Network's webinar, Icky, Sticky Science Investigation. I love that name, Amanda. Amanda Hackney will be our presenter this morning. My name is Alice Jansen, and I'm the Education Events Coordinator with the Texas Children and Nature Network, and we are very excited to have you all with us this morning. Automated closed captioning is available for this workshop. You can click the Show Caption CC button on the Zoom toolbar for the live transcript options. We are recording our session today, so to save bandwidth, we ask everyone to please turn off their cameras and mute themselves during the presentation. I will be monitoring the chat so that you can share your questions there, and I will share them with Amanda during the Q&A portion of the presentation, and we do have an interactive piece this morning. I will be sharing the link of today's session in a follow-up email next week. If you are uncomfortable with your name showing, you can change your name to anonymous and then private message me with your name for our attendance. I will be taking attendance. I'll be talking about that more in a moment. Also, if your Zoom name does not match the name you registered with, please change your name or private message me with your name. All right, this next part is very important, so please listen carefully. Only registrants that attend the live webinar are eligible to receive a certificate of completion. We do not automatically send all attendees a certificate. You must request the certificate after attending the live webinar. The email you received with the webinar Zoom link has the specific instructions for requesting the certificate. Attendance is taken during the live webinar, and we will check our attendance list to confirm your participation. We do need the name you registered with to issue the certificate. I'm going to go ahead and read our land acknowledgement. The Texas Children and Nature Network is headquartered in Austin, Texas, and as such, I am on the ancestral and unceded land of the Tonkawa, Comanche, and Sana people. Our ongoing colonial presence on indigenous lands compels us to take action now to counteract the effects of colonization. The work we do through the Texas Children and Nature Network is one small step towards that effort. I will put some information in the chat to learn more about the land acknowledgements and these indigenous peoples groups here in a moment. All right, so we have a very special webinar planned for you all today on Icky, Sticky Science Investigation with Amanda Hackney. She is a principal and consultant with Black Cat GIS and Biological Services out of the Houston area. Thank you so much for being with us here today, Amanda, and I'm going to go ahead and let you get going. Thank you.
All righty. Again, thanks y'all for making it on a Saturday. So yes, my name is Amanda, and I currently work, I do so many things. My background's in science, wildlife and fisheries. And from an education standpoint, I have done a whole lot of informal education. I've worked in a lot of different zoos. I have taught in the classroom pretty much everything from 3-year-olds to 90-year-olds. What I'm showing you today is taking the scariness out of teaching the scientific method. But this is actually an adaptation of something I use. I teach at a local community college, environmental science. So this is a very much an adaptation of something that I've actually used in the classroom for several years that always gets their brains going and really tries to make the scientific method very user-friendly, if that's possible. In the chat, I did put a link to Black Cat GIS /stop. So today's information is here on this website. So blackcatgis.stop. We are also going to be referencing the Texas Litter database, which is txlitter.org. That is also in the chat. Right now, this database, this website is going through some growing pains, and it's not terribly easy to add things to it right now. So that is why the education resources are on this other website. But you can see the lesson plan here. So if you'd like to download that while we go along, it's right there. It'll pop up as your PDF. We've got some introductory information for you. For those of you in Texas, we do have our science TEKS listed out, but we will be going through everything here today. We've got background information, and then we actually get into the methods, and everything's written out pretty well so you can follow along. We also have an Excel data entry file that you can download and use. This is set up. There's a blank. I filled in some dummy data here for us to play with later. But all of these categories are ready to go, as well as a pre-made chart. So as you fill things in on this side, your chart will fill out. So the Excel file is available. And then lastly, the data sheet that you'll need. So this is the data sheet that we will be referencing today. So if you want to have that to look at, again, that is all there at blackcatgis.com/stop. And you can just hit the jump to educator resources to bounce down there really quickly. So with that, let's get into Icky Sticky Science. So let's talk a little bit about trash, talk a little bit about litter. I like to refer to it as feral trash. We see a lot of it, whether trash is intentionally dumped on the ground or it escapes from a trash can, blows out of the back of a pickup, for those of you in Texas. Whatever way, it escapes captivity, right? Here in the Houston area, we have a lot of rainstorms, and a lot of our trash gets flushed out through parking lots, streets, neighborhoods during big rainstorms. Those of you out in West Texas, I know wind is much more of an issue. So when the wind picks up, wind is blowing it into the kind of those lower elevation areas. And as all of this progresses, we get trash eventually into our waterways. Those waterways go into bigger waterways, go into bigger waterways, and eventually they do get into the Gulf of Mexico or other large oceans, bodies of water. Now, where we start to have problems, well, obviously, throughout that stage, trash can actually pile up and cause flooding issues. If you have drainage systems that have like a log jam of plastic bottles and garbage, they're not going to do their job when there's a big rain and flood events happen. So this is a human health issue. It can cause flooding. It's kind of a nice breeding ground for bacteria and lots of gross stuff. So, the whole thing, in addition to it being terrible for wildlife, wildlife will ingest trash. As trash rolls around in the water, it breaks down, it becomes smaller and smaller and smaller. And we end up with what we call microplastics. Microplastics are just tiny, tiny, tiny pieces of trash, plastic that have rolled around and gotten smaller and smaller and smaller. Ingestion of any kind of trash is not good for anybody, whether that be a human or a bird or my happy little shark there. So yeah, we really want to talk to students about what the issue is with littering, how trash can be a problem, not only to the environment, but to human health as well. So that's kind of the litter life cycle there in all its glory. So, how did we get here? And, we've had a shift to a lot of plastic-based packages. So even our clothes, I'm wearing polyester today, which is made of plastic. We don't really see Coke in a glass bottle anymore. I have this very retro ad here talking about the first lightweight plastic bottle of Coke. And I can remember being in high school and people started selling bottled water in a plastic bottle. And we were like, that is so dumb. Why would you buy water when you can get it out of the tap? And now almost all of us are buying it regularly. So this is also an opportunity for you to bring in kind of some thought and thinking about maybe social studies and how consumer habits have changed over time. So we've got a lot more plastic. That's a problem. Among the 8 billion tons of plastic that we've made since 1950, 60% has been discarded in landfills or in the natural environment. And when you see, you'll see here on the screen, this citation, Le Pen 2018, I'm not pulling numbers out of thin air. I'm giving you information that is coming from scientific journal articles because I want you to have the best information possible. So all of these numbers are the results of scientific studies. It's not just random stuff I found on the internet. picture's random that I found on the internet, but hey. So yeah, most of the plastic that we've created is still here and hanging around. So doesn't matter where you are, you have a direct line to the Gulf. I don't care if you're in Dallas. Well, El Paso's got a little bit longer ways to go, but eventually all of our waterways do drain into the Gulf of Mexico or your nearest ocean. So there was a really cool study by, I'm going to butcher this name, Schultzka, in 2015, that estimated that oceans take in roughly 8 million metric tons of plastic in a typical year. So this is the equivalent of taking 5 grocery bags, 5 plastic bags from the H-E-B, the Kroger, whatever, full of trash, full of plastic on every foot of coastline. So imagine that stack of 5 on every foot of coastline in the countries that they examined in that study. So the plastic trash, kind of a big deal. So let's talk about some real world numbers and Keep America Beautiful. So right now I am a contractor for Keep Texas Beautiful, and Keep Texas Beautiful is an affiliate. It's part of Keep America Beautiful, which is nationwide. And Keep America Beautiful has been going for a long, long time. They have several programs all about beautification for the neighborhoods, for cities. And this ranges from anything from tree planting to litter pickup. So they're not just the trash people, they do a whole lot of things. But they did this really cool study. And if you go to the KAB website, you can look at their litter study information there, and it is fascinating reading. These guys literally hid in the bushes, watched people litter, came out and asked them questions about why they littered, and then had a whole lot of mapping and information about where litter was and what the composition of it was. So in this study, they found that there was more litter near waterways than on roadways. And like I said, that makes sense, particularly in my area, because of the rain effect. When it rains, everything flushes out. It just becomes like one big toilet bowl here in Houston. Everything goes into the bayous. So you can see how many billions of pieces of trash were involved in this study. And when we look at a breakdown of those items, one of our most littered items was actually cigarette butts. And you wouldn't typically think of cigarette butts as being a plastic item, but that little filter in there, the paper, all of that, you see it when you stop at a stop sign. There's that little snowdrift of cigarette butts in a pile. That's one of the most common items that they found. Plastic films was right up there. General use, so like our plastic bags, garbage bags, things like that, but also plastic films that were involved in food wrappers. And this is something that we've seen a lot in our local studies in Texas. And you've also got the pie chart there that shows you the types of litter that were found in this study. So the majority of it was plastic, 38%. Then you got paper breakdowns. And if you look at the Keep America Beautiful information, they've got historic data going back to the 70s or 60s. And, you know, glass and metal used to be a much bigger percentage of the types of litter that they were finding. So I've got some information on the lesson plan that links you to some of these resources, but also feel free to go to that website and play around and get some great background information. Have your students play around, read that information online. Really great stuff. So like I said, trash flows downhill. Technically, Dallas, Texas has a bay. So Dallas, Texas drains into the Trinity, and that actually drains into Galveston Bay. So Galveston Bay Foundation, one of the things they often say is, hey, Dallas, you have a bay. So yeah, remember when you're talking with your students, you know, show them these images, show them how all of our rivers are moving down and concentrating there on the coast. Okay. So I'm running through that information kind of quickly because we're starting a little late, but I want to talk about the scientific method. So, and this is Dino. Dino was found on a beach in Pasadena, Texas in we found him in 2020. We estimate that Dino, based on his materials, was made in the 1970s. So there's a little fun fact for you, trash archaeology. And what you see in front of Dino, those little round things, are actually called nurdles. So nurdles are baby plastic, if you will. Those are produced in mass here in our part of the world. They're produced, they are put in big shipping containers and sent to factories that make them into toys or water bottles or whatever. And nurdle escape is a huge problem. They are small. It's like grains of rice in your hand. So there is a separate program if you're interested in it, Nurdle Patrol, and I can put that link in the chat later. Nurdlepatrol.org. Nurdle Patrol does regular surveys for these things, and they do offer free sets, education sets for teachers. So just an FYI there. Let's talk about the scientific method. So we've got, the number of steps is going to vary depending on what source you look at. And when we're talking about our TEKS, I've got grade 4 up here, but most of these TEKS are kind of copy paste for the most part. We're really looking at our scientific processes TEKS. We are covering things like the safe practices in the field. We're talking about wise choices in the conservation of resources. We are covering the plan and implement descriptive investigations. A few parts of this section 2, but we are really honing in on this section 3. And I know the TEK numbers vary a little bit depending on the grade, but for the most part, we are really hitting this section hard. Okay, so we are hitting those numbers, so you can check those off your list for the year. So the first thing we're going to do is we're going to make observations, and this is where you talk to your kids. You don't really give them any background information yet. Just start asking them questions. What is litter? What do you know about litter? How does it make you feel when there's a lot of trash in a spot? Why do you think people litter? Just kind of get them thinking about it and talk to them about what's going on in their neighborhood. Really just get them thinking about it. And the way that what I'm showing you today is set up, you can do this on campus. So you could also have these observations about something on the school ground. Hey, have you guys noticed trash around the fence in the playground? Why do you think that trash is there? Who do you think put that trash there? So get them thinking about it. For the next step, we're going to do some background research. And this is where you can show some of the information from Keep America Beautiful. You can go online and get some information. You can have them, if they are older students, do a little background research yourselves. Keep America Beautiful has a lot of great resources. NOAA, the National Oceanic Atmospheric Administration. Bonus points to me for remembering that acronym off the top of my head. So NOAA has a lot of information on marine debris that's great. And one thing I want to remind you that maybe isn't really commonly known, when we say marine debris, that isn't necessarily ocean related. You could say aquatic trash. Anything that's in the water is what we're talking about when we say marine debris. So feel free to use those oceanic references, even if you're pretty far inland. So the next stage is to create a hypothesis. And we want a statement that's going to answer a question. So in those first 2 stages, we want to have them start thinking about, what kind of question do we want to ask? Easy things for you to do are to compare 2 different parts of the school grounds. We're going to compare trash near the parking lot to trash on the playground. Or do we think there's going to be more plastic trash in a survey versus paper trash? So we need to kind of think about what our overall question is. What do we want to answer? And when you come to the hypothesis, you're really just regurgitating that question and making it a statement. And that statement should be able to be answered with yes or no. When you are creating that hypothesis, so let's say we're looking at the parking lot versus the playground. I want to make a hypothesis that's something along the lines of, we expect to find more trash or more number of trash items in the parking lot than we would in the playground. So that we can definitely say yes or no to. When you are creating a hypothesis, you want to look for those descriptive words that you can check that box, yes or no. So things like more, greater than, less than, more items, heavier weight, things like that. You want to make sure you work those into your hypothesis. And this is a part where when I'm doing this with my students, I'll write it on the marker board, and that first sentence they're going to throw out there isn't going to be very close to what you're trying to lead them towards. So, we kind of play this little game where, I write down that first statement and I'm like, well, we could be more descriptive. So let's take these words out. What could we put in here to make this more descriptive? And they'll throw some more words out. And that sentence may go through 5 or 6 different iterations or more. So just kind of lead them along and try to get them thinking about that hypothesis. Now, when we create a hypothesis, especially for your older kids, you want to talk about what the independent and dependent variables are. So an independent variable is what the scientists are physically changing. So in the school ground example I gave you, my independent variable is going to be my location, my parking lot versus my playground. My dependent variable is what I don't know what it is. I have no clue. That's what we're trying to see what's going to happen with it. So the dependent variable would be amount of trash because I haven't collected that data yet and I don't know. So, have them think about what are we physically changing? What are my different categories here that I'm comparing? Right. And for those of you, I love the Amoeba Sisters, even though I teach, kind of the younger levels in college, high school, I use their materials quite a bit. So they have a lot of great sources out there. This is one of theirs that shows the difference in independent and dependent variables. So our dependent variable in this example, they're looking at eco-friendly barnacle boat paint. We're going with a marine theme today, I guess. So the dependent variable is related to what kind of paint we choose. So our independent is the brand of paint. And what we don't know is how well these different paints are going to perform at preventing barnacle growth. So that's our dependent variable. We don't know. That's what's going to respond. So we go through, we do our hypothesis, we figure out our variables. What do we do next? We're going to go do the tests, the experiment, the survey. So that's where you're going to haul your kids out to a safe outdoor area to collect data. And I'm going to talk about some different options you can do for that. But, your most basic, like I said, you've got them in the parking lot, you've got them in the playground. They could be doing different parts of the playground. They could be, and if you absolutely cannot get your kiddos outside, it's kind of gross, but you could do a trash audit of bags of trash that are already there collected in the cafeteria or something, which, let's be honest, cafeteria trash is pretty gross. Been there, done that. So you could look at composition of trash in your classroom. They go through the garbage can there and tally what's in it versus other areas. I will say I do a lot of work with trash and I realize it's very gross. Definitely have gloves available, disposable gloves, very, very important for this whole operation. And I know that trash is not everybody's cup of tea. I will say outdoor trash tends to be, at least in our area, kind of dried and not as gross as, say, something straight out of a trash can in your classroom. And I know you're going to go back and be like, yeah, I did this webinar and this lady was like, dig through the trash, do science. But hang with me. It gets better. You're going to see some cool stuff. So step 4, we go out and we do our tests. We do our experiment. After that, we're going to examine our results. So that is where the Excel table comes in. We've got our data sheet that we have recorded everything on. And that is where you can bring in those additional math TEKS, looking at a chart. How do we plot things in a table? What's the average number of this versus that? So go over your results. And then our last step is whether you support or reject your hypothesis. And that is why it's so important to set them up for success with a good hypothesis at the beginning. That yes, no statement is incredibly important. And at this point, you'll go through your results. You'll have them reference their results to support or reject. And as a group, you'll just talk through it. With my students, I normally have them do a lab report at the end of an experiment. Those of you grading lab reports is not fun. I do not enjoy grading lab reports, but if that is something you want to do with your class, making sure they have that good foundation and having those variables set up and understanding the hypothesis and understanding the results will lead them to success when they get to that discussion section at the end of their lab report and they write up whether they want to support or reject their hypothesis, which again, that's going to be upper level students, high school kiddos, and so on. So we're going to go through these steps kind of one by one, and we've got a pretty small group. So feel free to speak up or, put it in the chat. And I'm going to kind of pop through this faster than I had intended because we got a little bit of a late start. But that first part, we're going to make observations. We're going to ask questions. So think about your school. Think about your situation. What are some observations that your students may make about your location? Anybody? Somebody? Observations about trash. How clean your park is? Yes, Junior. Yes. Yep. And so I am thinking about my Lee College site where I teach. And yep, trash gets stuck on the fence line. I was just about to say something like that. We actually have a train track because it's Baytown near our college. So there's generally a lot of trash that blows up against that train track berm, and it's near a road, and we get a lot of trash over there. Anybody else have some observations if their students might make? Trash gets stuck on the fence line. I like that one. Any others? Last call. Nope. More trash around holiday parties. Oh, Lord, girl, I could talk about this forever. We see so much trash on beaches and community parks after things like the 4th of July and New Year's. Everybody likes to go shoot off firecrackers, and that firecracker makes a lot of trash. And you talk to the county folks who have to clean it up. They do not care for those big federal holidays. Trash gets stuck in flower beds and against the bushes. Yep, great one, Sandra. Actually, that is something we have found. And back up here a second. The STOP method that we're going to be talking about, what you're going to be working with your students. This is actually something that we're doing as a citizen science project. And we have done these STOP surveys all over the state. Most of them have been in Houston because this was kind of our pilot area first. But this data is actually being used by scientists, including myself, to analyze and try to figure out where trash is worse. And I like these observations y'all are making about the flower beds and the vegetation, because that's actually something that we have found out in the real world. If an area has more vegetation, more plants, whether it be grasses or shrubs or bushes or what, along a waterway, there's more trash there. And that's because it gets caught. Now, that's a good thing and a bad thing. It makes that place more trashy, but on the other hand, it is catching that trash before it gets to a larger waterway. And then Gabrielle added trash on college campus parking lots. Yep, everything blows out of cars, out of trucks. That feral trash, that is where it escapes quite often. So great, y'all are making some very good observations. So that next step, we're going to do some background research. And I did have, let's see. So take it to that take it to this page, which is a great resource. But you can see all of their research and resources here. So they can read more about trash. There's some great graphics, but you can get your students kind of thinking about, what's going on in that wider world. And of course, they want you to email a PDF. It's been a while since I've gone on this website. But there's a lot of great information available here. And we also have, let's see, what else did I want to show you? The NOAA debris website. So NOAA has a lot of great education information here for all different ages. So we do have some fact sheets that are easy to grab. And then you also have more activities and lesson plans here as well. So a lot of good places for them to explore and get that background information going. So you guys, we're going to kind of cheat. We already did our background research. We talked about it. So let's move to that create the hypothesis stage. So you guys, let's come up with a hypothesis that we want to test. Let's think of a fictional area and kind of throw me some hypotheses. Yes, more than one hypothesis. Kind of throw me some examples of that in the chat, what you can think about. So I'll start and put our example down. There will be more trash items found in the school parking lot than in the playground area. Oops, it would help if I could spell. So I just popped that in the chat. So that's a hypothesis that I can definitely test and do a yes, no. So y'all take a second, think about it, and pop some hypotheses in there for me. I'll give you, let's take 2 or 3 minutes to think about that and pop those examples for me in the chat or speak up. You can totally yell those out loud. Going everybody all at once. Let's see. Let's see if I can pop some other ideas in there. All right, got some great ones in there. Junior, there will be more trash debris caught in waterways after it rains, like creeks. Yep. After a flood event, we always see kind of that high tide line. Sorry, I'm on the coast. That high water line. And yep, we will get more trash kind of collected at that high water, that flood stage. Oh, Heather. There will be more plastic straws in kindergarten class trash than 4th grade. That is a great one. And I laugh because I have done a lot of summer camp work with zoos, and me and Capri Sun boxes, man, that's trying to get those straws in. So many straws. Yep, more plastic straws in kindergarten class trash than 4th grade. That's a great one. I threw one on there. There'll be more plastic bottles in the trash collected than any other item. So let's say you only have time to do one site. You can have them think about the composition of the trash. So there'll be more plastic bottles, or there'll be more plastic items in the trash. Sandra's got a good one there. I would expect more trash where people are fishing and snacking than in parks. I've done a lot of these trash surveys all over the Houston, Galveston area, and anywhere people sit around for a while, there's going to be more trash. Beer bottles, Coke bottles, Cheeto wrappers, and cigarette butts. That's what I find at every single fishing spot. So yeah, that is a great one to test. Gabrielle, I love that you're bringing in that northern experience. You'll find more trash after snow goes away. We don't have a lot of experience with that in Texas, but yes, I could totally see that trash that accumulates over the winter and just kind of goes into those layers. And after snow melts, all that trash kind of flumps there on the ground. So yes, great ones. You guys have come up with some great hypotheses. And on these, you can think about your independent and your dependent variable. I think most of them that you have, your dependent variable is number of trash. So yeah, Heather, yours, the plastic straws in kindergarten versus fourth grade. Your dependent variable is going to be number of straws, and your independent variable is going to be your classes. So yeah, great ones. You guys are doing very good on those. Thank you for those inputs. So now we're going to go out and we're going to actually pick up trash. So, safety first, whether you do it there on the campus or if you get field trip money or you have a park that you can walk across the street and do it, take them on over. And that is where the STOP method comes in. So STOP stands for study, track, remove. The O is big there, and prevent. I didn't come up with the acronym. We were trying really hard to make something work. So we just call it the STOP method. And in the STOP method, you're going to set up the study area. And, when we're talking to our students about science and measurable science, we want things that can be compared. We want to control as many different variables as we can. If we're going to compare the parking lot to the playground, we want to make sure that it's the same exact size that we're doing, because we'll make like a little subset. We'll cordon off a little square and be like, all right, kids, this is where we're going to do our test. In the case of kindergarten trash versus fourth grade trash, maybe we want to make sure that we do one lunch session for each grade or each age group. We don't want to do 2 kindergarten age groups versus 1 fourth grade group, because then our numbers are going to be skewed. You want to compare apples to apples here, right? So when you set up your study area or your different categories, you want to make sure that they're comparable. Next thing you're going to do is you're going to have them pick up every single piece of trash that you see. And when I say every single piece of trash, you want to get any piece of trash. We say a cigarette butt or larger, or if you don't want to say the word butt in front of small children because of the giggles, you can say the size of a Coke bottle cap. Okay, but about that size or larger. There are different projects that look at microplastics, so smaller amounts of trash, but that kind of gets into some different categories, and you need more technical equipment. So we're looking at what we call macro trash, big trash. So you want to pick up every single thing they get, put it all in a bag or multiple bags, because trying to get kindergartners to put everything in the same exact bag when you have 20 of them running around, that doesn't work well. So give everybody, when we've done this with younger students, we've given them, give everybody a HEB little plastic grocery bag. And then everybody brings it to the teacher or the instructor later, and we put it all in one big pile. Or, if you've got high school kids, you can have maybe groups of 2 working together with bags, but collect all that trash. And after you've collected all the trash, you are going to record your number of individual items on the trash report page. And I'll show you that data set here, or that data sheet here in a second. So I realize you're probably not going to want to haul your students down to a stinky, dirty bayou, but this is one of my transect examples. So what is a transect? I keep saying that word. In science, if I want to know what's going on in a larger area, so let's say I want to know what my most dominant plant species are in a prairie or in a park. I'm not going to go out there and count every single blade of grass and every single wildflower and every single bush. That's going to take way too long. So I'm going to take a sample, right? This is just like when we do around the time of election season, right? We get those phone calls. People are doing the political surveys, and they are calling a subset of the American public that they can then use that subset to make inferences about the larger population, right? And when we take a sample, we can use our sample and do some algebraic magic, get some algebraic equations in there. We can take our sample and then multiply it by whatever factors to get the number for our whole. So let's say we have a fence that's, I don't know, you measure your fence and it's 2,000 foot of fence line, right, around the playground. And your student sampled 50 foot of it. Well, then you can bring him back in the classroom and say, oh, you know, we did 50 foot, there's 2,000 foot total. What do we multiply 50 times to figure out the amount of trash that's, you know, around the entire fence? So that is why we set up a transect. We don't want to sample everything. It's going to be a lot to clean up the entire playground. Although if you've got enough kids, go for it, or it's not that trashy, go for it. But we do these things called transects. And what a transect is we measure out a length, and our kind of standard length is 100 foot. Now, you may want to do a smaller amount, especially if you've got little guys or the place is really dirty, or you may want to do a larger amount. Maybe you've got high school kids and you need to keep them busier. That's fine. This is totally adaptable to whatever you need, okay? So once you set up that transect, and I do have, let me pull up the lesson plan here for a second. I do have here in our instructions some good guidelines on setting up your transect. So you want to define your start and your end points really well. It's good to find really identifiable start and end points. So landmarks around the school. Okay, we're going to go from the end of the sidewalk to the edge of the swing set, or we're going to do the football stands from this corner right here to that corner. Ooh, doing these under football stands, that would be after a football game before they clean up. Find some fun stuff there. But after you figure out the size that you're going to want to do, I do the transects because, you know, you've got that straight line. And then I normally say, okay, we're going to go 10 foot out either side, 20 foot out either side. This was a bayou, so it was me and my college age interns doing it. So we were doing kind of just a shoreline study. But if you're doing it there on campus, you may want to do 20 to 30 feet out each side of the transect, or you may want to say, okay, the fence is one edge of our study area, and we're going to go 30 foot into the playground. Make sure your students understand what the study area is, whether that's borrowing some cones from the PE department and putting cones around the area, or putting up some rope to kind of delineate that area. Make sure everybody understands where we're picking up trash. And if they want to pick up trash on other parts of the playground, that's cool, but keep that separate from your good trash, your study trash. And this will allow you, once you know the size of your study area, you'll be able to calculate your total area. So again, that's bringing in math, that's having them think about how much trash per square foot. So once we got that going, we've got our transect set up, you'll get your data sheet. And the data sheets are there on the website. You can print them out. They'll fill out some basic information. And again, this is our citizen science project, so you may not want them to fill out the contact name and contact email and stuff. But they will have these little hard and solid plastic categories. So notice on our data sheet, we have things in large categories like hard plastic versus metal versus fabric. But then we also have individual items listed. So like, I'll be able to tell you how many plastic bottle containers versus how many shoes. Y'all, the people of Houston must be barefoot, because I have found on average, we find about one shoe, and that's not made up information, that is related in stats. We usually find about one shoe per 100 foot of shoreline when we do one of these. We'd be losing shoes everywhere. So you've got the categories, and as they go along and they count the items, they will make them little tally marks, and then they can total them up right here. And this is an example of one of our cleanups in the San Luis Pass area. So what do you need to do this? Here's kind of our suggested list. Trash bags of some kind. You can also use buckets. Clipboards, very useful. Things are always very windy here in Houston, so don't want your data sheet to blow away. You got to print your data sheet, have those pencils, have those gloves. If you're doing this kind of in a more wild area, definitely suggest maybe trying to source some of the, more work style gloves. If you're doing it there on campus, you're probably fine with the disposable gloves. Trash grabbers with older kids are okay. Younger kid, well, any age group, they turn into swords at some point, right? And everybody's poking each other with them. But the trash grabbers are nice. They're not a necessity. Really, your basics are those bags, your data sheet, gloves, I would say, is a basic. You also need a measuring device of some kind. We've used measuring tapes. We have actually a pre-cut piece of rope that's 50 foot long. So we've strung that out before and then, kind of swapped it around to do 100 foot. The buckets and the baskets are useful for sorting. That's not a have to have, it's a nice to have. We like to put a tarp down. That's a nice to have thing too, because when we're sorting trash, we can have the kids dump all of their trash there on the tarp, and it's kind of easier to clean up afterwards. And if you'd like to collect information on weight, which also gives you another cool metric, you can use a fishing scale. And this is one here. We get this one from Academy. It's kind of our commonly used one. It's one of the fancy high-end ones because it's digital. This one's about $19. And you just this is for fish technically. You can either clip your bag here, you can hang it there on the hook, because we always lose the clip pretty quickly. And you hold it up off the ground and it'll show you the weight of your bag. So that's another nice metric that you can have. So when we do the actual test, these are a couple of my interns sorting the trash, and we can sort the trash into categories. And this is kind of the method that's worked best for us. We have them sorted by material first, and then we can kind of get into more distinct groups. Here, so you can see our glass pile, there's our aluminum can pile. We do have a PPE category. Here's our fishing line pile. And you're going to have your kiddos, after everybody sorts stuff, you're going to have them count individual items in the categories. So, and then we're going to tally those on the data sheet. So we're going to do a quick little practice here. And again, I have my Excel sheet. So as we go through these, I'm going to enter my data here. This is kind of some dummy data that I made up. So you can adjust these columns to whatever you want. You can add more columns. If you do add more columns, you'll need to adjust the data coverage on your chart. But let's look through this right quick. Let me put my thing over here on the other screen. All right, so somebody shout out a real quick count. So this is all my plastic bottles. So we're going to simulate what's going on here. Let's see, 1, 2, 3. I already lost count. 1, 2, 3, 4, 14, 15, 16, 17. All right, so I've got 17 bottles there. Notice one is not a beverage bottle. So I had 16 bottles and one. So the way I would enter this, come on, guys. So let's see, I would say 16 bottles or containers. And for that oil container, I would come down here. Let's see, I have a category. Non-food container. So that's where I would put that oil bottle right there. So there's our first set of trash. And we do have a category for hazardous large items / large. So like this is a household battery. If I remember correctly, this was part of a boat GPS unit that we found. So, you know, y'all are more than welcome to count along as we go here or start yelling out stuff. Let's see. So 3, 4, 5, 6, 7, 8 glass bottles. So I go to my data sheet. Glass, what did I say, 8. And for all of these categories, we do have other. So if you find something that just doesn't fit anywhere else, that's fine. You know, pop it in the other. You don't have to put description. It's all there. And that happens fairly regularly. Oops, did I put something wrong? Yeah, got it, 8. All right. So we've got that on there. Make this a little smaller so it's easier to bounce back and forth. On my material up there, let's see, I've got 1 household battery. I don't know, let's see, I don't think the GPS mechanics there fit in anything, so I'll just put 1 other for large and hazardous. Okay. Here's the good old film pile. And this will be, I will tell you from experience, this is one of the bigger categories of things you'll be entering. So many Cheeto bags that I picked up, y'all. So it looks like maybe 1, 2, 3, 4, 5-ish plastic film bags. We'll put 5. Food or drink wrappers, I'm just going to guesstimate because we're kind of in a hurry. Notice I've got the ketchup container here. So 1, 2, 3, 4, 5, 6, I don't know, let's put like 7. We've got our aluminum cans there. So we've got just 3 cans. We do keep track of bottle caps. One thing that's interesting for your students is bottle caps and plastic bottle beverages hardly ever match up in number. There's always more bottle caps. We do metal separate. So it looks like 1, 2, 3 metal caps. And then what, 1, 2, 3, 4, 5, 6, 7 plastic. We also have what looks like a metal pull tab for maybe some Vienna sausage. This was actually collected at a boat ramp where there's a lot of fishing. So let's see. Oh, I put that in the wrong spot. Oh, that was right. I'm gonna put other for that cap. We've got like a hard plastic thing here. So I'm going to put that as a non-food container. So I'll make that 2. This is a food container lid. So I'll put 1 for my hard plastic. And when it comes to hard plastic versus plastic film, plastic film, if you can crumple it up in a tiny ball, you know, like a Cheeto bag or a shopping bag, then I call it film. If you crumple it up partially and you get some resistance, I put it in the hard plastic category. We've got our good old soup can. So we'll add another one here. So aluminum and tin cans are the same category. I do have that PPE category. Fun fact, we actually started this project in February 2020. Project got shut down pretty quickly, as you can imagine, because of the pandemic. So we had to kind of pivot and get very creative about those first few months. Looks like we have 3 cigarette butts. So I'll put those here. So in the interest of time, I was going to have you guys go through and do some of these in the breakout rooms, but we are running a little short. So we'll just kind of, I'm going to describe these. We're not going to enter the data right now. You will sometimes, especially if you go to a boat ramp, get these big snarls of fishing line. And what I can tell you is to just do your best at guesstimating. Look at the different colors, look at the different thicknesses, and just be like, okay, that's 1, that's 2, that's maybe 3, that's a different thickness 4, just kind of guesstimate. Here's the fun thing about this science. It is, especially when it comes to things like that, just a guesstimate, because when we go to some of these bayous, there is no way we can pick up every single tiny piece of trash. It's just not going to happen. So sometimes it is a bit of a guesstimate. You will also notice at the top of the data sheet that we have estimated fragments. So when you get out there, and maybe there's a styrofoam is notorious for this, there's a whole lot of little teeny tiny styrofoam fragments. You can have your students put in an estimate, and we can say, all right, there's a whole lot. I bet there's between 199 fragments. And they can circle that instead of sitting there and counting every tiny little piece. But we have the fragments on every one of the categories, except for the large items. So we're going to bypass the rest of that in the interest of time. So the next thing we're going to do is we're going to look at our results. So let's pull our Excel sheet back over here. Oops. Multiple screens. This is live theater, folks. Sometimes it doesn't go the way you want. So everything pre-filled here on my chart, and let's make him a little bit bigger. So I've got my count site 1 that I'm comparing to my count site 2. So count site 1, looks like I have a whole lot more bottle caps than I did at number 2, but you can start to make these different graphs. You could have them, draw these by hand, make it an art project. You could have them cut out squares or pictures or something. You could do it on the wall. We're going to tape a square for every item that we found, and let's make a big chart on the wall and look at it. So there's a lot of ways you can get creative with your data and talk about comparing it. But this is another time where you can pull in those additional TEKS for math and such. You can talk about how we need to have certain things on our charts, like a title, and we need to have labels for our axes and our legend and things like that. So we look at our results, and then we can come through and support or reject our hypothesis. So let's pretend count site 1 was my parking lot, count site 2 was my playground. We could do a total sum of items here. Let's see, let's do a sum. Data, formula. Oops, no formulas. Auto sum. Let's see, auto sum, and I want that all the way up. So 60 versus 47. So if this was my parking lot, I can say, yes, we proved my hypothesis correct. There were more trash items in the parking lot than there were on the playground. I hope there are not beer bottles in the parking lot, but hey, that was the example we had. So if you want to go a step further with this, you can look at the Texas Litter Database. And again, this is a citizen science project. So what your students are collecting is actually stuff that will be used by people in my profession. So like Houston Advanced Research Center is using it. Keep Texas Beautiful is using it to try to understand where trash is, where the hotspots are in the state or beyond. And, how, if we understand where trash is a problem, then we can start to look at the variables, look at the characteristics of a site that might make it a problem. So when your students do one of these and you enter the data on the database, it becomes part of a huge science project. So that's something that's really kind of cool for the students is, this isn't just us messing around and doing something in class. This is actually contributing to a larger project to try to do change. I get asked quite often, well, what's the end goal of the database? Why are you doing this? And I answer, my job, I'm just the dirty scientist that crawls in and out of the dirty bayous. I collect the data, I make pretty maps, I make pretty charts, and I give that to people, in my case, that's like the Texans for Clean Water group that goes and lobbies at the state level for change to try to prevent some of these litter problems. So my people that are trying to make political change, they need data on the ground. So that is where the Texas Litter Database fits. And it tries to make this information available so that we can make policy changes. So this is the Texas Litter Database, and I'm going to give you a quick run through. So if you are interested in entering your data, which I totally would love for you to, we do have a lot of different user guides on how to create an account. We are not going to spam you. We are not going to send you, we're not going to sell your email. We're not going to do anything like that. That is too much work. Everybody involved on this project has a lot going on. I'll show you what my account looks like. So I'm going to sign in right quick. And I realize we're running short on time. I might go over maybe 5-10 minutes with questions. But you'll make an event. So like when I do a cleanup, so like we'll look at this guy here. This was a cleanup with one of our folks here in Houston that was running for city council, I believe. And I can look at my report here. So actually, let's go back. Let's say I want to make a new report. So if you wanted to make a new report, enter stuff with your kiddos. Right now it's pre-filled because that one had stuff on there. But if you wanted to, zoom in, let's see, there's a school right here around the corner. So let's say we did one right here on these school grounds. I can also look at the satellite. So, oops, that is someone's house, not the school. My bad. We were over here. Let's say we did this parking lot. I can put a little point because having that location information makes it more valuable for us as a scientist to understand where in the world this trash was happening. So you can either type in your lat long or you can look on the computer and do it that way. You'll fill out a few basics, your numbers of trash, and you don't have to fill out everything. If it's required, we have a little red star. Do realize that a lot of different groups are using the database, so some put in more information than others. But down here's the meat of the problem. You guys are going to be doing the stop method. And down here is where I would enter. So I would put in so let's say I did not 100 miles, 100 feet. And I would turn this on and I would say, yes, I had 4 or 5 or whatever. But I would drop all these categories down and put in the number of information. So let's say I had some others and so on. And then I would hit submit. I'm not going to hit submit because this is kind of a fake demo really quick. But yeah, that is how you would use the Texas Litter Database. Oh, I also wanted to show you. So let's go back. Yeah. We also have these maps and charts available. So they're up here. I can go to maps. Yep, and remember, all of this is going to have TEKS connections. So if you are specifically trying to check those boxes on reading charts and reading scientific information, this is where you can get some of these. So, and this is a great place for you to also show them, and when you're doing that kind of reference material on step 2, trying to get background information. So you can zoom in on different points here. And I can see information about a survey that someone did there. This isn't all the categories, but it is kind of the major ones. So they can look at maps. You can look at places done near your hometown. Let's go to Nacogdoches. That's my hometown. So you can explore different points here. These guys didn't report stuff. They just reported their count. That's okay too. I can also look at the heat map, so I can see where the larger numbers of trash were happening. So that's something you can use, and maybe this has social study TEKS connections as well. Or I can look at charts. So we have a lot of different charts on here, and they're pretty cool because you can customize them all. So let's say I just wanted to look at, let's say, hard plastic and plastic film. I can turn these other categories off, and we're just looking at this information that was picked up on all these surveys over time. I can also adjust my period here on the chart. Another cool thing about the charts here is you can save them. So if I wanted to save that image to use later in a presentation or a homework, I could do that, and I would have that picture ready to go. So there's all these charts that your kids can explore and play with and look at here available for you. We've also got our running tally of information. Lastly, you can do a data download here. And what this is going to do is it's going to spit all of the information in the database out in a Excel table. So essentially you'll have one of these with tons and tons and tons of information in it. So if you wanted to use that data for maybe an in-class analysis, or use it for maybe some math problems or things like that, that is available too. Okay. So I know I just threw a whole lot of information at you, and it was a lot. With that, I will take your questions. I do have, oh, wait. I forgot to show you some other resources for you. So I am also involved with this group called Splash, Stopping Plastics and Litter Along Shorelines. They are concerned with marine debris in terms of bird habitat, but Splash actually has a whole lot of education info here on their website, including additional lesson plans on marine debris. And you can click on these guys and they'll take you to additional sources. But again, everybody here is TEKS aligned. They also have an educator's guide. If you are here in Region 4, they do have toolkits available. And then there are some great videos on here if you want to show stuff to your class that give some background information. They actually use the same exact surveys, the STOP surveys. So they do go over some of the surveys in some of their videos. And my personal favorite are the coloring and activity books that you can print out and use. Also, when it comes to Keep Texas Beautiful, you have affiliates all over this state. So if you are in an area and you're like, well, I'd love to have maybe some help with garbage supplies or whatever, you can see contact information for these different groups that you can talk to. Maybe they can come. I'm not going to speak for every group here, but they may be interested in helping you with some education activities or a cleanup there at the school. Now, with that, I think I've shown you all the toys that I know of. I will take your questions. There is my contact info there. Again, my name is Amanda, and I have the website again, blackcatgis.com/stop is where you will find the education materials for today. And yes, thank you, Sandra, for the reminder that we have more TEKS coming. I did teach in elementary some, and I'm not a fan of TEKS either. I'm with y'all on that. So thank you for the reminder that TEKS are changing.
Thank you so much, Amanda. That was wonderful. We appreciate you speeding up your presentation to be able to fit within our time frame. If anybody has any questions, you're welcome to put them in the chat, or we're a pretty small group, so you're welcome to unmute and ask your question verbally. So please feel free to go ahead and do that. I'm putting some information in the chat about different things, but I put the evaluation for today's webinar to give us feedback. And then also our upcoming webinar is on October 4th. Once upon a time, there was nature with Sandy Sita. She is a high school student from Frisco, Texas, who is very active in environmental conservation and justice issues. So that'll be a fun one to hear from a youth leader. I'm about to drop some information in the chat about our, well, I put some information about our summit already. The summit for Texas Children Nature Network is coming up December 6th through the 8th in Houston, actually, at the C. Baldwin Hotel. So if you're, especially if you're in Houston or in Texas or even in Maine, you're welcome to come join us for our annual educational event. We have lots of wonderful keynote speakers. We have Parker McMullen Bushman. We have Dr. Melissa Lim from Canada, who's a doctor, and she also started the Park prescription program there in Canada. And we have 13 hands-on field-based workshops on that Wednesday of the summit, which will be out and about around downtown Houston and other areas. I put some information about becoming a summit sponsor. We are still looking for sponsors for this year. So if you know of anyone, please share the information. And if you have a really good lead, please let me know, and I can give you all some more resources, sample request letter and things of that nature to share with any potential sponsors. The event is called the Texas Children in Nature Network Summit. So I can just grab that link again really quickly. We call it the summit. So hopefully you all can join us for that. It's a wonderful opportunity to network. We have several social networking opportunities during the event. On that December 6th, after the workshops in the evening, we are having a Texas Children in Nature Network night out, which will have lots of fun activities. It's going to be in Buffalo Bayou Park. The cisterns will be illuminated and open for our group to tour. We're going to have the Houston Public Library out doing a version of a star party with telescopes and stargazing binoculars and things like that. We're going to have some folks doing some dirt play activities from Asakura Robinson. Yeah, so lots of great things going on. This is an opportunity to go ahead and ask any questions while we have Amanda here. I just put some information about becoming a partner. If you're not an official Texas Children in Nature Network partner, it's a really simple process. You just fill out the form after you've read our strategic plan and agreed to our plan and our mission. And then if you would like to see continuation of these wonderful webinars that we bring you all, we encourage you to make a donation. We do offer them free of charge. We are a nonprofit organization, so we welcome any donations to support our programming and resources for our network partners.
And if anybody has any questions, maybe you think of it later, feel free to email me. So my email is there. Also, one of my part-time folks, Leanne Wilde, she's my education and outreach person as well. If you are an informal educator and you would like us to come do a training for your agency or your nonprofit, we will totally do that. We have grant funding to cover this right now. So it's free. So let us know. It says training in the Houston area, but we will travel a little further than that. So yes, thank you all so much for hanging out today.
And as I said at the top of the webinar, I will be sending out a follow-up email with the recording and with some of these resource links that have been shared during the webinar. You're also welcome to grab this information from the chat. And yeah, we'll be following up with lots of good stuff. Thank you all for participating, and sorry for the delay in getting started and for the issue with the Zoom link. I'm glad that you all made it. Otherwise, it was just going to be Amanda and I hanging out, talking about trash, getting trashy.
So trashy.
Yes, so trashy. So hopefully you all can take this information back and use it in your classroom with your educational programs that you all are working on. So be sure to fill out the evaluation to give us information about other potential webinar topics you'd like to see from us. Awesome. Okay, everybody, we appreciate your time and your participation. I'm going to go ahead and close the meeting, and y'all have a great rest of your Saturday and take care. Thanks again, Amanda. That was wonderful. We always appreciate having you, and I'll be following up with you soon as well.
Sure. Thanks a lot, guys. I appreciate it.
I thank you all.
We'll be trashy.
Stay trashy.